Hello, we're now going to continue our look at assembly code, specifically in the little man computer instruction set, by talking about branching, which is a really, really important concept. This video is focusing on the selection part of branching. We'll look at iteration in the next video. So what are we talking about here? Well, like in high-level languages, assembly code typically will execute line by line, top to bottom. This is what you might call a sequence block of code. By default, it just executes top to bottom without any breaks. In high-level languages, we're able to use if statements and loops to break this typical behavior, and we use branching to do that in assembly code. So branching is where we, instead of following this sequence line by line approach, we jump to execute an instruction outside of this normal sequence. So jump is a word we can use here. We jump between lines. That's what branching is. Now, we don't, arguably have branching in high-level languages. We have things like if statements and switch statements for selection. For iteration, we have things like for loops, while loops, do until loops to break the normal sequence of execution. In assembly code, we have branching, which can implement selection and iteration because we haven't got any if statements or any loops. All we have to use are our branching operations, BRA, BRZ, and BRP. So BRA branches always. This runs no matter what. Kind of similar to else potentially, where if nothing else is run by that point, it will run, but we could have BRA on its own, unlike else. BRZ runs only if the value in the accumulator is directly equal to 0, and BRP only runs if the value in the accumulator is 0 or positive. Now, because I've only got these 3 branching operations to play with, I need to basically bend all of my questions to be able to use one of these 3 instructions or a combination of them. So even a relatively simple question like asking the user to enter a number, if it's greater than or equal to 10, output 10. If it's less than 10, output 0. That is pretty simple to do in a high-level language. I just use an if statement with else, and that does the job. Even something like this becomes a bit more hard to do in assembly because I have to use one of our branching operations or a combination of them. So let's do it. I want to ask for you to enter a number. That bit I can do using imp relatively straightforwardly. Our inputs are only really ever numbers in assembly code, or at least in little man computer. We don't ever have strings input. It's always numbers. So the question variety is quite limited in assembly code. But we're asking the user for a number here. And if it is 10 or greater, we output 10. If not, we output 0. So how am I going to do this? How am I going to bend my question to fit the 3 assembly code branching operations? Well, if I, for example, subtracted 10 from the input, if the resulting answer is positive, it must mean my input is bigger than 10. Conversely, if I subtract 10 from my input and it's a negative number, therefore my number was smaller than 10. So that is the main approach, or the approach I can see to answering this question. I need to subtract 10 and see if it is a positive or negative number, which I can use because I've got BRP, which is branch if positive. So I need to be able to subtract 10 from my input. I can't just go sub 10 like this because 10, when shown like this, is a memory address. So the way I've shown you how to do this so far is we use a dat line of code where I would go something like 10 dat 10. We set the label 10 to be equal to the value 10. And so if I replace the literal 10 with the word 10, now it will let me actually subtract 10 from the accumulator. So I input a number, it's in the accumulator, I subtract 10 from that value, and we can see what is there. So if I just output this, and it's halt just so I do things properly, I load it into RAM, you can see stuff appearing in RAM in the simulator, which I talked through in the last video, so I won't go back into that now. If I run it and type in 15 now, we should get 5 output. And so now I can check, is 5 positive? If it is positive, then I know my input was bigger than 10. So instead of outputting it here, let's instead use our branching operation, BRP, branch if it is positive. Now, the way we implement selection in assembly code, which is what I'm trying to do here, is to use labels. So let's just choose a label name. Let's say greater as a label name. Labels need to be one word. They can have numbers in, but they are typically quite short. They could be capitalized, but I prefer to do them lowercase. So we can immediately spot selection in assembly code when I've got a branching command, but I'm branching to a label further down in the code. So if I now use my left-hand column and write the word greater over here, I can write some code here which can get jumped to. So at this point, if our accumulator has a positive value, the code is not going to carry on and do whatever is here. It is going to jump to where it sees this label. It's going to skip the lines where I've got the question marks currently if it is positive. If it's not positive, it just carries on. So if it's not positive, it would do whatever I've put here instead. So let's just handle what I need to put next to greater. If our input is greater than 10 or equal to 10, I wanted to output 10. That was sort of the question said. Bit of a silly question, but we are limited with what we can do in assembly code. So if I want to output 10, what I should probably do is load in 10 into the accumulator and then output it. And that's it for that part of our branch. If I didn't load in 10 again, we would just have whatever the kind of resulting calculation was in the accumulator. It was 5 in this case. I don't want to output 5, I want to output 10 if it is greater than or equal to 10. So let's get rid of these question marks because that's going to break stuff. I could put an out here just to put something, but this code shouldn't ever run if I type in a number greater than or equal to 10. Let's try 15 again. I should see 10 this time, not 5, which I do. Let's try that slight edge case where I type in 10 itself. 10 minus 10 is 0. So 0 will be held in the accumulator. BRP treats 0 as if it is positive, which is a little bit silly, but that's how BRP works. It's useful to know that. In this current form of code, if I run it again and type in, say, 5, well, 5 is less than 10. Here, I get minus 5 outputted, then I get 10 outputted. So why on earth do I get these two outputs when I typed in 5? Well, let's trace our code. I input 5, 5's in the accumulator. I'm subtracting 10 from 5. So 5 minus 10 is minus 5. I then am checking BRP. Well, minus 5 is not positive. So therefore, this line of code doesn't run. Therefore, we don't jump. We just continue. We output the contents of the accumulator, which is minus 5. Then it just continues. So despite us not jumping to greater, I still end up at greater because the program just continues line by line unless it is being told to branch. So we load in 10, we output 10, then we stop. So what I need to do, instead of us branching, if it doesn't need to branch, if it is a negative number, I need to, according to the question, load in 0, output 0, and then end the program. So I'm going to load in 0. I haven't created this as a variable yet, so let me do that at the bottom, 0.0, and then I can output that 0. What I do need to do is add in another halt if I'm going to do this, because if I run it now and type in 5 again, 5 less than 10, therefore I should get 0 outputted, which I do, but then I also get 10 outputted. Again, that's just because it is just continuing with the execution, despite it not actually branching to greater. It just continues on. So I want to stop that prematurely. I want to halt my program before it gets to the greater than code, so if I don't see this additional 10 being output. I load it into RAM again, I run it, I try 5, I get 0 output this time. If I try some more values, if I try minus 5, I still would get 0 outputted. So this is solving that question. This is the equivalent of that relatively simple if statement. That example showed a situation where we have two branches that either runs one bit of code or another bit of code. Let's have a look at an example where we would effectively have 3 branches. So again, a very simple question. It's a doddle to do in a high level language. I want to ask the user for a number, output 1 if it's positive, 0 if it's 0, and minus 1 if it is negative. Well, I've got 3 different possible things which are going to happen here, which makes our assembly code a teeny bit more complicated. Again, you look at the question, you think about how can I sort of, work my way around the branch operations to implement this code. Well, BRZ is going to be really useful here because I'm going to want to check to see if this user's input is equal to 0. I can do that quite easily using BRZ. After that, I could check whether it's positive quite easily using BRP. And then if it's not either one of those two, it's going to be negative. Therefore, I can check if it's negative by just using BRA, for example. So let's do this in the simulator. So we're going to start with user input like we almost always do. And as always, it's going to be a number. And now I can just use BRZ straight off the bat. I don't need to do any subtracting here because BRZ is just going to tell me whether the user's input is 0. Remember, branch operations are checking what is in the accumulator at that point. Well, the input is being held in the accumulator, therefore BRZ can check if that value is 0 or not. If it is 0, let's branch to an is 0 label, which I'm just going to put further down in my program for the time being. If it is 0, I want to output 0 itself. Well, if it is 0, then the accumulator already has the value 0, so therefore I could just do out because it's already 0. Then after this point, I could halt my program if I wanted to. And I could try this straight away by running it. I type in 0 and I get 0 output. If it is not 0, then it's going to ignore this branching instruction and just carry on. So the next line of code could check to see if the input is positive, which I can use BRP to do this. Remember, BRP does also include 0, unhelpfully, which is why I had to put BRZ before BRP so that BRP wouldn't run if it was 0 inputted. So I can branch this time to a label called isPos, maybe, which again, I'm just going to put further down, doesn't really matter where. If it is positive, the question said to output 1. Well, it's not always going to be 1 in the accumulator, so I need to actually load in the value 1 here. So I can use LDA and I could use a DAT line of code. Don't forget, we need to make sure the DAT line of code always come at the bottom, which can be difficult doing it in an exam because you've almost got to remember, well, if you were doing a line of code like this, you would make a mental note to yourself to write in a DAT line once you finish with the rest of your code. So that can be a bit complicated. Make sure DAT lines are always at the bottom. So you do those lines of code last. We have to do it last so that it doesn't overwrite any of our previous memory. Once I've loaded in 1 into my accumulator, I can output that. And to prevent it just continuing and running my 0 code, I can halt it so that it doesn't run the code ahead of it. Let's try this now. Load it into RAM. I type in just a positive number now. Let's type in 8. I get 1 outputted. Let's try some more numbers. Let's do 29. I would get, again, still 1 outputted. And if I type in 0, let's just check I still get 0 outputted. Yes, I do, because it's checking BRZ before BRP. Now, what do I do if the input is negative? Well, if it's negative, BRZ won't run, BRP won't run. So therefore, it's just going to continue into this line of code over here. So actually, I don't actually need to use BRA in this question, it turns out, because I can just load in, it was -1. Might just call that -1, doesn't really matter what it's called. And put -1 there. And then I can output -1 once we get to that point. Again, let's halt it so if it doesn't just keep running, it stops at that point. Load it into RAM. Let's run it, and let's try a negative number, -6. I get -1 outputted, so that seems to be working as it should. Let's do a final example where we're going to ask the user to enter 2 numbers, and we're going to output the smaller of these 2 numbers. Well, we're going to start with an input line like I've done in every example so far. Now, how am I going to bend my branching operations to fit this question? Well, to see which one is bigger, again, I can use the trick of subtracting one of them from the other and see if the result is positive. If it's positive, it means the first number must have been bigger than the second number. So I'm going to need 2 inputs here. And what I would think we should do here is make sure both of these inputs are saved to memory, because the second I do another input like this, our first input is just being erased because the accumulator is being overwritten. We definitely need to store our first one, but I think storing our second one as well is just sensible. So to store values in memory, we use SDA. And the best way to do it, you could be like SDA5. This would store the input in location 5 in memory, but we typically use labels to do this. Let's call this label num1, and let's do the same with our second input and put it in a label called num2. And then when we use DAT, which we have to right at the bottom, it will automatically allocate our space in memory to be able to do this. That's why the DAT lines go last, so if it doesn't overwrite anything previously. So now both are kind of safely stored in memory. So I can probably see this if I type in, say, 77 as our first one and 35 as our second one. We can see 77 and 35 held in memory. It's chosen location 5 and location 6 for us, but it's just chosen the next 2 free locations. Okay, now how am I going to do this? Well, I said we're going to do some subtracting. Currently in the accumulator at this point, we have num2 because that was the last thing we dealt with. So if I did sub num1 now, I'm subtracting num1 from num2. And if this is positive, it must mean num2 is bigger, as in our second number we typed in was bigger than the first number. Let's branch, if that's positive, to a second label where we're going to just output. In fact, no, we can't just output what's in the accumulator because what's in the accumulator will be the result of this subtraction. So I need to load back in num2, output num2, and then halt my program. Let's try this. So let me load it into RAM, run it, and make sure my second number is bigger than my first number. So 5 is my first number. Let's do 8 as my second number. We do see 8 being outputted there, which is a good early sign. What do we do if num1 is bigger than num2? Remember, this subtraction is me subtracting num1 from num2. If num1 was bigger than num2, we'd get a negative result. And because I've got BRP here, if it was negative, it would just not run this code. It would just continue into the lines down here. So therefore, at this point, I could just load in num1, output num1, and let's not forget to halt as well. Otherwise, it would just continue running the code below it. Let's try this now. Load it into RAM, run it. Let's do num1 being bigger than num2. Let's do 15 as num1 and 5 as num2. We do get num1 outputted. So this is our code done at this point. If I typed in numbers which are equal, because BRP also includes 0, it would still work. It just outputs one of these numbers, which are obviously the same here. So don't forget that not every assembly code question will be you writing code. There might be some where you have to write code and they can be tricky to do on paper. I definitely understand that. It's why doing practice in a simulator like this is really important, so you can see if it's working and you can try and debug it. You may not get it spot on in an exam situation, but you can get hopefully close to it. And in branching and selection, we need to always branch to a label further down. Those are the sort of basics you would be expected to understand in an exam. And they might give you some code as opposed to you writing it yourself and ask you to be able to trace it or interpret it. So it's not only writing, it's understanding it as well. Now, the only one I didn't show you in this video was BRA, because the questions I chose didn't naturally lead to it. BRA runs no matter what is in the accumulator. So to give you a quick example of how it might be used, I have got 2 halts in this program. Some people might prefer to only have 1 halt and do something like end, so that we could jump to this end if I needed to. And that means I could do something like BRA halt here. And because it's BRA, it doesn't matter what's in the accumulator, it's going to branch no matter what to, sorry, not to halt, it's going to branch no matter what to end. Therefore, it would jump no matter what to this end line and halt. That's the equivalent of me having halt in 2 places. It does the same thing. So give yourself some questions to do, maybe give it a day or 2 and then replicate the questions I showed you here to see if you can do this and get it working.